Hello, 7th graders. Today we're going to talk about solving inequalities. When we are solving inequalities, the solution to an inequality is the set of numbers that make the inequality true. So for example, if we have x is greater than 2, it would be all of the numbers that are greater than 2. Any of those numbers, 3, 4, 5, 6, 7, and so on, could all be x. To find our solutions, we need to check to see if a number is a possible solution by substituting the value in for the unknown variable and simplify both sides of the inequality. If the resulting inequality is true, then it is a solution. If the resulting inequality is false, then it is not a solution. So in these next couple of examples, we're going to tell if the given value is a solution to the inequality. Well, looking at number 1, it says 18 is less than 3x minus 10. If we plug 7 in for x, we have 18 is less than 3 times 7 minus 10. Well, on the left side, we just have 18. On the right side, we have 3 times 7, which is 21, and minus 10, which is 11. Is 18 less than 11? No, so our answer would be that it is not a solution to the inequality. Looking at number 2, we have to replace x with 1/2. So on the left, we have negative 8 times 1/2 minus 13. And on the right, we have negative 9 minus 20 times 1/2. So looking at the left again, we have negative 8 times 1/2, which is negative 4 minus 13. And that's less than or equal to negative 9 minus 20. 1/2 of 20 is 10. And on the left, we have negative 4 minus 13, or plus negative 13, giving us negative 17 is less than or equal to negative 9 plus negative 10, which is negative 19. Is negative 17 less than or equal to negative 19? No, so our answer would be it is not an inequality, a solution to the inequality. For number 3, we're replacing x with negative 16. So we have negative 16 over 4 plus 5 on the left, and that is greater than negative 3 times negative 16 plus 13 on the right. So on the left, those negatives actually make a positive. It would be like a negative 1 times that negative 16 fourths. So we have positive 16 divided by 4, which is just 4 plus 5. And 4 plus 5 is 9. That's on the left. On the right, we have our parentheses first, order of operations, negative 16 plus 13 is negative 3 times negative 3, which gives us 9 on the right as well. So 9 is greater than 9. Well, that's not true either, so this still is not a solution to the inequality. Last one here, we have number 4, where we're going to plug in negative 3 for x. So we have negative 3 squared minus 14 is greater than or equal to 3 divided by negative 3 minus 4. Well, on the left, negative 3 squared, or negative 3 times negative 3, gives me 9 minus 14, and that's greater than or equal to 3 divided by negative 3, which is negative 1 minus 4. Well, 9 minus 4, or 9 plus negative 14, is negative 5, is greater than or equal to negative 1 minus 4, negative 1 plus negative 4, negative 5. Well, since it's not just greater than, it's greater than or equal to, this is true, and it is a solution to the inequality. We solve inequalities just as we do equations, with 2 differences. We always graph our answer, and every time we multiply or divide both sides by a negative, we have to flip the way the inequality sign is going. Remember, it'll be easier if you move the smaller variable term first when there are variables on both sides of the inequality. So these first 2 examples of when you would flip the sign. If we are solving this inequality, I might want to draw my train tracks. I would first undo that 7 using inverse operations, and on the left, those go away. I'm left with negative 3x. On the right, I have negative 5 minus 7, or negative 5 plus negative 7, which is negative 12. Lastly, I'm dividing by a negative 3 to get that x by itself. Well, like we said, if we divide by a negative, we're going to flip that inequality. So now I have x is greater than 4. When I go to graph it, just like yesterday, we put 4 in the middle, 1 below, 1 above, an open circle, since it has the greater than sign, not greater than or equal to, and it's going to be drawn to the right. Number 2, I'm once again going to solve this. I'm going to subtract 13 first, just like I would if it was an equation, and on the left, I'm left with negative x over 2. On the right, I have 17 minus 13, which is 4. To undo that dividing by 2 or dividing by negative 2, if I put that negative there, it'd be the same thing as multiplying by negative 2, or the inverse operation would be. So on both sides, I multiply by negative 2, and on the left, I'm left with my x, and since I multiplied by a negative, I once again have to flip my sign. It's going to be greater than or equal to negative 8. Going to graph that, I have negative 8 in the middle, negative 9, and negative 7 on the right. Since it's greater than or equal to, I have a closed circle, and I'm once again drawing that arrow to the right. Here are 2 examples of when you would just leave the sign as it is. So when we go to solve this, I first want to subtract my 3 from both sides, and I get negative 14 on the left, and I'm left with 7y on the right. Lastly, divide by 7, divide by 7. Well, now I divided by a positive 7, so I'm going to leave that sign as it is. Negative 14 divided by 7 is negative 2, and of course, I have to rewrite this with my variable on the left. So I'm going to flip that inequality to y is less than negative 2, and then you can go ahead and graph that. For number 4, it's the same idea, but first I have to combine like terms. So I have negative 6 plus 8x giving me 2x plus 5 on the left is less than or equal to 3. Next step, subtract 5 from both sides, and I get 2x on the left is less than or equal to 3 minus 5, which is negative 2. And the last step, divide by 2 on both sides. X is less than or equal to negative 1. I did not have to flip that sign because once again, we are dividing by a positive 2. And then you can go ahead and graph it. Go ahead and pause the video and try these next 2 on your own. So for number 5, we have 3x minus 3 minus 2x is greater than or equal to 12. So the first step here is to combine like terms. I have 3x minus 2x, and that equals 1x, or x. I'm left with minus 3, can't be combined with anything else, and that's greater than or equal to 12. Next step, add 3, and x is greater than or equal to 15. And then you can go ahead and graph that on the right. For number 6, we have negative 3m plus 5 is less than negative 7. So when I go to solve this one, the first step is to subtract, there's an announcement. The first step is to subtract 5 from both sides. The 5's go away. I'm left with negative 3m on the left, and that's less than negative 12. Negative 7 minus 5 is negative 12. My final step is dividing by a negative 3. And since I'm dividing by a negative, I have to flip my sign to greater than. I'm left with m is greater than 4. And you can go ahead and graph that on the right. Last 2, pause the video, try them, and come back and see how you did. So the first step for number 7 is that we have to distribute that 3. So 3 times 2 gives us 6, and 3 times g gives us 3g. So minus 3g is less than or equal to 18. Next step, I have to subtract 6, inverse operation there, and I get negative g left on the left, and that's less than or equal to 12. Last step, divide by negative 3, divide by negative 3, and I get g is greater than or equal to 4. Once again, we divided by a negative. We had to flip the sign. Last one, we have variables on both sides, so we have to get them to the same side. I'm going to subtract out the smaller term with the variable, which is 0.9y. When I do that from both sides, 7.9y minus 0.9y gives me 7y is less than negative 7. Lastly, divide those 7s, and you get your answer.